because I think my storage is full.
Recording in progress.
Okay. So, what chapter do you want to learn? Like, do we have to do all three chapters, or can we pick one chapter? Um, I'm not Okay, let's do electrochemistry. That. Can you make me share screen? Okay, so do you have any questions on electrochemistry? So, okay, can you make me share screen? I think before I can share screen, I just closed my Zoom tab. Can you see my screen? No. Oh, wait. Can you see now? Actually, I cannot see your chat. Do you have any questions on electrochemistry? Oh, okay. So there in right? So this is a jar, and then this is the electrolyte. Terus And then there is the electrodes. Yeah. So this is electrodes. So the positive one is anode and the negative one is cathode. So there are like two types of electrolytes. There are molten electrolytes. And there is aqueous electrolyte. So if it's molten electrolyte at the cathode, it would produce metal. Sorry for my ugly drawing. And at the anode, it will produce nonmetals. And for aqueous electrolytes at the cathode, there is two. So like the metals go to the cathode, right? And then in the cathode, the one with higher reactivity than hydrogen produces hydrogen. And then the one with lower reactivity produces the metal. And then at the anode, if a halide is present, it can either be concentrated or diluted. So if it's concentrated, there's a halide and it's concentrated, the halogen or the halide will be produced. But if it's dilute, oxygen will be produced instead. And if halide is not present, then oxygen is formed. Can you read my writing? Do you understand? If you don't understand anything, you can ask. Can you like see me flipping between screens or do you just see one screen? Oh, okay. If you have any questions, you can ask. Oh, okay. Um, so like wait. Okay, so this is the solutions, and then you have to say what is produced at the cathode and anode. So this is number 1, number 2, 3, and 4. If you cannot read, just tell me. cathode sodium, anode chlorine. Aduh, I udah hapus. Okay, so this is dilute, right? And if it's dilute, aqueous sodium chloride. Okay, so it's aqueous. If it's aqueous, the sodium or the metal at the cathode needs to be the the one needs to be hydrogen, or the one that has lower reactivity than hydrogen. So sodium is the metal in the solution, and sodium does not have a lower reactivity than hydrogen. So therefore, hydrogen will be at the cathode because it's aqueous. Like if it's molten sodium chloride, then it will be sodium, but it's aqueous. So yeah, hydrogen. And then now the non-metal is chlorine. And the chlorine is a halogen. It's like in the group 7 of the periodic table. If it's a halogen, then it will be formed at the anode, but it's a dilute halogen. So if it's dilute, oxygen is going to be formed at the anode instead. So if it's concentrated, it's gonna be the halogen present, like chlorine. But if it's dilute, it's going to be oxygen. And then for sodium, if it's aqueous, sodium is gonna no. If it's aqueous, the metal that has a lower reactivity than hydrogen is gonna be formed. But if it's not, then hydrogen. The one that has a lower reactivity than hydrogen is antimony, bismuth, copper, silver, and gold. Yeah. So try to do the other ones. Like if you don't understand what I'm saying, please ask. Yeah, so number 2, it's actually chlorine, but it's not lithium. Yeah, so number 2 is hydrogen because lithium is higher in reactivity than hydrogen. Okay, wait. Let me show you. So this is the reactivity series, right? Anything that is higher in reactivity than hydrogen, like lead, tin, nickel, cobalt, cadmium, iron, chromium, zinc, manganese, osmium, magnesium, calcium, strontium, barium, lithium, sodium, and potassium, if if they are the metals in the solution, then hydrogen will be produced instead in an aqueous solution because they are higher in reactivity. But the one lower than hydrogen, like antimony, bismuth, copper, mercury, silver, gold, and platinum, will will be produced instead of hydrogen in an aqueous solution because they are lower in reactivity. So in here, the metal is lithium and it's an aqueous solution. And lithium is more reactive than hydrogen. Therefore, hydrogen will be produced instead. Like, do you understand? Okay. Try to do number 3 and 4. So if like in aqueous solution, if the reactivity is higher than hydrogen, then in cathode is hydrogen or the opposite. So if the reactivity is higher than hydrogen, then in cathode, yeah, if the reactivity is higher than hydrogen, then hydrogen is produced in the cathode. Yes, very smart. Like, do you want me to explain like the whole thing to you again, yung before, until you understand? Or do you think you already understand now? Um, no, the metals, the aqueous only affect the metals. So aqueous is with metals. So copper kan metal. The aqueous affect the copper. Tapi if dilute and concentrated, it affects the non-metal like chloride, bromide. Yeah. The non-metal is affected by dilute or concentrated. not non-metal, the halogen. The halogen is affected by concentrated or dilute, but the is only affected by aqueous, so it doesn't matter if it's dilute or concentrated for the metal. Okay, okay. Let me explain it again. Yang tadi. Eh, in better handwriting, so you can understand. Okay, so there are two types of molten electrolyte or solution. Ada yang molten and aqueous. So if it's molten, there is cathode and anode, right? In molten electrolytes, the one produced at the cathode is the metal. So for example, sodium chloride, molten sodium chloride, the one produced at the cathode is the metal in the solution, which is sodium. And at the anode, the ones produced is the non-metal. So in sodium chloride, the non-metal would be chlorine. That is for the molten one. So the molten ones is straight up, like it's simple. The metal at the cathode and the non-metal at the anode. But then in aqueous electrolyte, the one produced at the cathode is either hydrogen or the metal formed. And that depends on the reactivity series. So if the reactivity of the metal is higher than hydrogen, the metal is more reactive than hydrogen, then hydrogen will be produced. But if the reactivity is lower than hydrogen, then the metal in the solution will be formed instead, like copper, silver, and gold. So if the solution, misalnya like tadi, copper something, copper copper chloride, then copper would be produced because copper has a lower reactivity than hydrogen. Do you understand that part? And then at the anode, kan ini aqueous electrolyte. At the anode, if a halide is present, halide is the group 7 of the periodic table. Um, so halide is group 7, which is this: fluorine, chlorine, bromine, iodine, acetine, and tennessine. The group 7 in the periodic table is called halogens or halides. So if a halide is present, like chlorine, fluorine, bromine, then it can form halogen or oxygen. And it depends if it's concentrated or dilute. If, for example, concentrated sodium chloride, then the halogen will be produced, which is chlorine. But if it's dilute sodium chloride, the halide is present, but oxygen will still be formed because it's dilute. And if a halide is not present, there's no halides, then oxygen will be formed. Example is like uh, mm, copper nitrate. So copper nitrate, nitrogen or nitrate is not a halogen. So oxygen will be produced instead in the anode. Do you not understand that? Like if you have questions, you can ask. Oh, okay. Like actually in the question, you only need to focus on the dilute and concentrated because all of the solutions here is aqueous. But for the metals, you also need to like focus on the reactivity series. The non-metals here is also all halogens, so like very easy. So all of them have halogens. You just need to like see the dilute and concentrated part. Okay. Okay, you can continue trying to answer it. Mm. Cathode copper, anode oxygen. Oh my god. Oh my god, it's correct. Congratulations. Now the last question. hydrogen gas cathode and oxygen anode. Hydrogen is correct, but it's not oxygen, it's bromine. Because this is concentrated potassium bromide, and if you see in the chart, if it's concentrated, then the halogen is formed. And the halogen is bromine. So it's concentrated, it's bromine. If it's dilute, it's oxygen. You understand? Yeah. So try another one. This number number 1, 2, 3, and 4. So this one have molten and aqueous solution. And if you remember, in molten solution, it's the straightforward one. So the cathode is the metal and the anode is the non-metal. Cathode lithium, anode oxygen. Yeah, correct. So the cathode is lithium and the anode is oxygen. So like if it's molten solution, the metal is in cathode, which is lithium, and non-metal in anode, which is oxygen. So very easy. Hydrogen gas cathode and oxygen anode. Yeah, correct. So the cathode is hydrogen and the anode is oxygen. Yeah, very, very nice. Okay, next is another molten solution. Calcium cathode, chlorine anode. Calcium cathode and chlorine anode. And then the last question. Oh yeah, sorry, this is concentrated aqueous sodium fluoride. hydrogen gas cathode, fluorine anode. Oh my god, yes. Oh my god. Okay, so you can do this already, right? Very nice. So next is how to write equations. This is half ionic equations. It's like this. Okay. It's like this for the metal and this one for the non-metal. So for the metal, metals are cations. Jadi metals always positive. So like Na is a metal, Na plus electron. This is an electron equals to Na. And then Mg2 plus 2 electrons equals to Mg. So the purpose of electrolysis is to like make the positives and the negatives into their original neutral no charge form. But for nonmetals, it's actually like different. So nonmetals are negative or anions. So okay, for example, fluorine negative equals to 2 fluorine plus 2e. So like why is it 2, right? Because in the first one there's like no 2, but then there is 2. It's actually because fluorine is a diatomic molecule. That means that it always has to be 2. So all the halogens, I think, is diatomic molecules like chlorine, oxygen, they all need to be 2 like this. Oxygen is O2 and hydrogen also is H2 and chlorine is Cl2. So yeah. And then bromine, I think bromine too. So bromine is 2 Br minus equals to Br2 plus 2e. Like, do you get this? This is just like if this is one negative, then well, it's plus 2 electrons because it's 2 fluorine. But for Na, it's 1 plus, so we need to plus it by 1 electron to make it no charge. And if magnesium, there is 2 plus, so we need 2 electrons to make it no charge. But like if you can see the difference between the non-metals and the metal is that they're kind of like kebalik. The metals, the plus ones are in the first and then the product is at the end. But then the non-metals, the first one is, well, it's not really the product because this is the product, but the product have like, plus plus. And you cannot like switch them. So if it's Br2 plus 2E equals to 2Br negative, it's actually wrong. So like it needs to be like this. Pokoknya it's backwards. Like just remember that. It's um inversely proportional. Oh yeah. And then to write equations, you need to know like the charge. Like why is magnesium plus 2 and why is sodium only plus 1, right? So to know the charge, you actually need to look at the periodic table. In the periodic table, there's 8 groups. 1, 2, 3, 4, 5. Okay, so there's 8 groups, but then in here, we're not gonna include the group 8. So you can write on your periodic table, the first group is plus 1 and then plus 2. And we're gonna skip this whole entire thing. We're gonna explain that later. But then plus 3, plus 4, minus 3, minus 2, and minus 1. So like it's like easy like that. So before magnesium is plus 2, right? That's because it's in the second group and it's plus 2. And then for example, fluorine is minus 1 because, yeah, fluorine's minus 1, chlorine minus 1, bromine also minus 1. So, yeah, that's like how you know. Like, do you understand? This one is how to find the charge like this. Magnesium, oh, magnesium 2 plus, and then fluorine minus, yeah, and then 2H plus. That's like how you know the charge. Okay, you understand? And then how about the ones at this group? Like what about the ones at this group? Like for example, we have iron, Fe, or copper, Cu. So usually they have what was it called? They have state symbols. So for example, in our first question here, we have copper 2 chloride. Copper 2 chloride, right? So this is called a state symbol, the one like inside the brackets. So if it's copper 2 chloride, it would be Cu2 plus because copper is a metal and metals are always positive. So copper 2 plus. So if it's like iron, iron 2 um iron 2 bromide, then the equation would be Fe2 plus because it's 2. Yeah. But if they don't mention anything, so if they just wrote like copper chloride without the state symbols, then it would just be Cu plus. But I don't think it's like that because like you need to memorize the charges and it got changed. Like it doesn't change. So yeah. Um yes. Okay, so I'm gonna tell you to write half equations. Okay, ini aja. Can you write the half equations for this? So I'm gonna give an example. Lithium oxide, the one at the anode. The one at the anode is lithium, right? So lithium is Li plus because it's at group 1, you can see there. So Li plus, and then metal is, and then lithium is metal. Anode. Oopsies. Cathode. So Li plus 1 electron because it's only plus 1 equals to Li. And then at the anode, yeah, this is half equations. At the anode, it's oxygen. So oxygen is it's 2O minus because oxygen is a diatomic molecule. So you need 2 equals to O2 plus 2 electron. Yeah, so try to do the other ones. Like if you don't understand, you can ask me. Yeah, like a clue. All of this is gonna be 2. So 2Br, 2Cl, and 2F because they're all diatomic molecules, like the oxygen. So they're gonna be 2. Like if you don't understand, you can ask me. Or like, do you wanna see the periodic table? Wait, I don't know if I can. Um. Oh, okay. Mg2 plus 2E equals Mg. Yeah. Okay. Actually, it's dilute aqueous, so it's like supposed to be hydrogen, but okay, it's okay. I'm gonna change it to molten. But actually, the answer is correct. So no, I'm gonna change it to molten. So I forgot to change it. They're supposed to be molten, not aqueous. Your answer is very correct. Uh yes. 2Pr minus equals to Pr2 plus 2E. Um oh my god, yeah, it's correct. Very smart. CS plus E equals to CS. Yeah, correct. To Cl equals to Cl2 plus 2E. Yeah, correct. Aduh, I think you forgot the minus. 2Cl negative. Never mind, you do. Yeah, very nice. Correct. A plus yeah, correct. And then the last one. 2F negative equals to F2 plus 2E. Yeah, correct. Yeah, so we're done. Tapi it needs 30 more seconds. So, yeah. Thank you for listening.